Hey everybody, I want to go through real quickly some of the first notes we're going to learn about for our chemical reactions unit. First, we need to remind ourselves of what a molecule is, right? A molecule is just more than one atom that's bonded together, and that happens either by sharing or trading electrons so they can sort of stick together. These chemical bonds, right, are forces that hold atoms together, right? That's not a stick that connects them. There's a force, kind of like a magnetic force or a gravitational force. It's a force that are nearby each other and held together by energy. And those bonds can be broken in order to release energy, or sometimes we make bonds, new bonds. We join new atoms together to release energy. So chemical bonds are just a force that holds individual atoms together into molecules. A chemical formula is what we call it when we write out the symbols and numbers that indicate what a molecule is for us, right? It's a short way to show which elements are combined together and how many of them. So, just like on the periodic table, each element has its atomic symbol, right? Hydrogen is H, carbon is C, iron is Fe. When molecules join together, we give them a chemical formula. And sometimes you're going to see numbers in these chemical formulas, numbers that are written below the line of the letters or just below are called subscript numbers. And that subscript number relates to the letter that it is just to the right of. So in this example here with H2O, uh, this 2 belongs to the H, not to the O. So there are 2 hydrogen atoms here. So you can see these 2 blue circles, and 1 oxygen atom that joined together. There's the one red. And this is kind of what a molecule of water, H2O, ends up looking like. A chemical equation then is sort of like a math problem almost that shows when 2 chemicals join together what they need in order to happen and what gets created in the end. So we have terms for what goes in and what comes out, right? Reactants are the things to the left of an arrow in a chemical equation. Those are what react together. Those are what start the reaction. And then products are what are created, right, in a chemical reaction. Now, we've got our subscripts in this case. You can see the blue number twos. In order to balance an equation, right, it says here, equations must be balanced. We'll get to more on that later. But in order to do that, often we need to write what are called coefficient numbers. Now, coefficients happen out in front of atoms or molecules, and it tells us how many of them there are in total. So we're going to be practicing this and dealing with subscripts and coefficients. So one of the things we need to be able to do is count how many atoms there are and which ones there are, and make sure that we understand how to write them in equations so we can start to balance them and do some real chemistry. So here's some steps in order for you in order to count atoms in a chemical formula. So first of all, you need to understand the difference between uppercase letters, lowercase letters, right, that we studied with the periodic table. So in this case, we have zinc because Zn, a lowercase letter next to the Z, belongs together. That is zinc. S is a capital letter on its own. That's sulfur. And oxygen is a capital letter O. That's all by itself as well. We have a subscript of 4 here. So there are 4 atoms of oxygen, 1 of sulfur, and 1 of zinc. Here's what it says in the next step. Count the subscripts, right? If there is no subscript, see how it says that here? That sort of means that it's just a 1, right? It's present, it doesn't have more than 1. So just as I said here, 1 atom of zinc, 1 of sulfur, and 4 of oxygen. Now, sometimes you're going to have coefficients. Sometimes you're going to have parentheses, right? And so in this case, we have aluminum, carbon, and oxygen together. There are 2 atoms of aluminum. The 2 belongs to the Al. Then we have parentheses. C is by itself. O has a 3. But both of those together inside the parentheses have a 3 outside the parentheses. So this 3 gets multiplied in. There's an imaginary 1 next to this C. So 3 times 1 means 3 atoms of carbon. And 3 times 3 oxygens means 9 atoms of oxygen. Now, it says the answer here for this one, but see if you can figure it out. There's a coefficient, there's some parentheses, there are some subscripts. See if you can explain why there are 4, 6, and 18 of each of these here.